We will first start with the overview and description of the apparatus. The upstream section of the apparatus is comprised of a supply reservoir and a sluice gate. The sluice gate can be lowered and raised using the crank shown. Water is conveyed from the supply reservoir through the channel. The downstream gate is located at the downstream end of the channel. It is used to control the flow depth upstream. Located at the downstream end of the channel is a discharge measuring tank mounted on a balance. This tank is equipped with a plug in order to block any discharge from it. Discharge is obtained by accumulating a certain mass of water over a known period of time. Finally, the blue valve is used to regulate the water flow through the apparatus and is located at the upstream section of the apparatus next to the supply reservoir. Now we will make sure that the apparatus is set up properly before commencing the experiment. First of all, water should be flowing in the channel. Also, the upstream sluice gate should be completely open. Then, make sure that the discharge tank is unplugged. Make sure that the flow depth in the channel is around 12 centimeters. And also make sure that the height of the downstream gate is about 5 centimeters. If not, please alert the teaching assistant. Now we will be going into the procedures of this experiment. The first step is to measure the width of the channel. About halfway down the channel, where the flow should be more stable and the water surface is leveled, measure the flow depth using the point gauge. The procedures for using the point gauge is as follows. This is an illustration of the point gauge and its adjustment screws. To measure the flow depth, turn the macro adjustment screw counterclockwise while holding the metal rod with your other hand. Afterwards, lower the metal rod gently until it reaches the bottom of the channel. Now turn the screw clockwise in order to fix the rod in place. Using the graduated scale, record the reading which corresponds to the channel bottom. Now, turn the screw counterclockwise and raise the rod gently until the very tip of the rod is just above the water surface. And then tighten the screw by turning it clockwise to fix the rod in place. Afterwards, use the fine adjustment wheel to fine-tune the tip's elevation such that it barely touches the water surface. The flow depth can be calculated by subtracting the first reading corresponding to the channel's bottom from the second reading corresponding to the water surface. The following is an overview and description of the pitot tube device. The upper screw is used to fix the pitot tube on the piece where the vertical alignment is found. The lower screw is used to fix the vertical position of the pitot tube on the vertical scale. The pitot tube device is comprised of two main components. The first is the pitot tube. The pitot tube is mounted on a sliding block which slides along the Y or cross-stream direction. The alignment of the pitot tube is determined by a line marked on the sliding block. The pitot tube is also capable of moving up or down along the vertical. The vertical and horizontal scales are used to determine the location of measurement in 2D. Please note that both these scales do not start at 0. The second component of the pitot tube device is comprised of two piezometers to which the pitot tube is connected. These piezometers record pressure at the pitot tube's static and stagnation pressure ports. Now we will be starting the velocity measurements. First, using the lower screw, lower the pitot tube as close to the channel bottom as possible, and record the position on the vertical scale. Then, using the small horizontal rod, make sure that the tube is vertical and that the lower part of the tube is parallel to the flow. Now slide the pitot tube as close as possible to one of the side walls. This will be the location of the first velocity measurement. For obtaining this velocity measurement, you need to record the readings given by each piezometer. After each displacement of the pitot tube, wait for the piezometer levels to stabilize before recording them. Afterwards, Slide the pitot tube towards the opposite side by adding the horizontal increment specified in the lab manual to the horizontal position on the scale. Then record both piezometer readings. Once the piezometer readings have been recorded 4 times between the two walls for this vertical position, raise the pitot tube such that it is about half a centimeter below the water surface. Record this position on the vertical scale. To determine the vertical increment, subtract the bottom vertical position from the one on the top, which was previously recorded, and divide that difference by 4. Now repeat those readings with the pitot tubes at the surface, 1/4, 1/2, and 3/4 of the flow depth by adding the vertical increment to the vertical position. The final step of the experiment is to measure the discharge. Note that this step can be performed at the same time while the velocity measurements are being taken, since the flow rate should be steady during the entire experiment. The measurement of the discharge will be carried out in the following manner. First of all, make sure you have a stopwatch at hand. Afterwards, lower the vertical metal cylinder using the horizontal handle. Make sure that the metal cylinder is perfectly aligned with the bottom hole and that no water is leaking from underneath the cylinder. Using a flashlight will help you detect and control any leakage. Begin recording the time it takes for a known mass increment to accumulate in the tank. Note that the greater the mass of the increment chosen, the more accurate the discharge measurement will be. Stop recording the time once the target mass has been reached. Afterwards, unplug the tank by raising the vertical cylinder to drain the water from the tank. Repeat the discharge measurement at least 3 times. This concludes the experimental procedures for this experiment. The following procedures are for the startup of the apparatus. First, make sure that the main valve of the apparatus is closed by checking that it does not turn in the clockwise direction. Raise the upstream sluice gate all the way up. Then, raise the downstream gate about 5 centimeters. Afterwards, ask the lab technical officer to start the main pump. Once the pump is on, adjust the flow rate using the valve in such a way that the flow depth in the channel is about 12 centimeters. Wait until the depth is steady and leveled. After this, place the point gauge and the pitot tube mount in the middle of the channel where the flow is most stable. Remove air bubbles from both piezometers connected to the pitot tube using the air hose in the vicinity as follows. First, disconnect the piezometer tubes from the pitot tube and remove the water from them. Afterwards, reconnect the piezometer tubes to the pitot tube. Next, inject water into the piezometer until they are full. Finally, gently use the compressed air to remove the air from the piezometer tubes, which is located between the water column and the sampling points of the pitot tube. The apparatus is now ready for use by the students. The following procedures are for the shutdown by the teaching assistant. First, close the main valve slowly by turning it clockwise. After this, ask the lab technical officer to turn off the main pump. This concludes the shutdown procedure for this experiment.